welcome you to the session. How do we enhance competitiveness of logistics and supply chain management using artificial intelligence and machine learning? I am Professor Jitesh Thakkar, Dean Academics and Professor Logistics and Supply Chain Management at Gati Shakti Vishwavidyalaya, India's first university in transportation and logistics sector, a central university sponsored by the Ministry of Railways, Government of India. I would like to introduce you to the channel Professor Dr. Jitesh J Thakkar. Currently, this channel has two playlists, faculty and student development, and second is logistics, supply chain and infrastructure projects. You can scan the QR code on the right hand side to explore the intellectual content on this channel, benefiting students, industry professionals, and faculty. About this playlist, Excellence in Logistics, Supply Chain and Infrastructure Project. In today's highly competitive business landscape, organizations that excel in logistics, supply chain, and infrastructure are better positioned to attract the business and thrive in the competitive landscape. Efficient logistics and supply chain management plays a vital role in ensuring efficient operations, customer satisfaction, and overall business profitability to ensure that the cost can be reduced, lead time can be reduced, and capacity can be augmented, utilization can be improved with improved customer service. Infrastructure projects are vital. Government of India is investing more than 100 lakh crore in the various schemes like Bharatmala, Sagarmala, Udan, and dedicated freight corridor to see that the infrastructure development can positively impact the economy of the nation and the GDP of the nation can really gain momentum. This playlist explores critical issues in logistics, supply chain, and infrastructure project for both manufacturing and service sector. I would be happy to introduce you with my university. Gati Shakti Vishwavidyalaya Central University was created in 2022 by the Act of Parliament. It is established by Ministry of Railway, Government of India, and it has a unique mandate to cover entire transportation and logistics sector, including rail, road, water, aviation, ports, and shipping. Across all three dimensions, technology, management, and policy, comprising multidisciplinary teaching, executive training, skilling, and research, university follows a demand-driven curriculum which is in line with the 21st century requirement of the nation and the industry. High quality faculty with global exposure and leveraging state-of-the-art infrastructure of centralized training institution sets the pitch for the university to harness the challenges of 21st century in transportation and logistics sector. GSV is propelling the nation towards a new era of interconnectedness and sustainable development through innovations and best practices in transportation and logistics sector. University follows the most contemporary vision, innovation-led and industry-driven university for creating, assimilating and imparting excellence of knowledge and action, accelerating development in the transportation and logistics sector. The mission of the university is to be best in the world, futuristic education and research, build on credibility, rigor and relevance, effective collaboration with industry, academia and various stakeholders, and imbibe and internalize professional work ethics and culture to foster lifelong learning paradigm for a developed India. University offers programs for both the categories regular students and working professionals. For regular student, it offers technology-based program in civil engineering, BTech in civil engineering, BTech in mechanical engineering, electronics and communication, BTech in electrical, BTech in artificial intelligence and data science. And you can see that each one of the program has specialization either in railway engineering or it is broadly transportation and logistics. It offers BTech in aviation engineering program with a focus on aviation maintenance and MBA in logistics and supply chain management, MBA in ports and shipping logistics. For working professionals, university offers the programs in a hybrid mode, MTech Intelligent Transport System, MTech Railway Engineering, MTech Bridge and Tunnel Engineering, MTech Roads and Highway Engineering, MBA Logistics and Supply Chain Management, MBA Metro Rail Management, MBA Multimodal Transportation, MBA Aviations and Operations Management, PhD in Engineering and PhD in Management, exclusively for working professionals in industry with a focus on transportation and logistics sector. Let us have a deep dive into the topic of this particular video, which exchanges the views on how do we enhance the competitiveness of supply chain using artificial intelligence, AI, and machine learning, ML. This video will help you to gain insights broadly into a couple of my contributions in AI and ML, introduction to artificial intelligence and machine learning, classification of AI and ML models, use of AI and ML models in logistics and supply chain, and the future of logistics and SCM with AI and ML. I'm happy to share my first contribution in the domain of AI and ML, where the recommender system based on sentiment analysis was proposed. So it is Senti-Ngram, an Ngram lexicon for sentiment analysis. The paper was published in Expert Systems with Applications, volume 103 in year 2018, pages 92 to 1045. So as we know, sentiment analysis helps evaluating the performance of products or services from user-generated content. So you see a lot of reviews, a lot of feedback on Amazon, Facebook, Twitter, and various social media, and you can capture the sentiments of the users. Lexicon-based sentiment analysis approaches are preferred over learning-based ones when training data typically is not adequate. Existing lexicons contain only unigrams along with their sentiment scores, and it was observed that sentiment engrams formed by combining unigrams with intensifiers or negations show improved results. So typically, this paper has adapted a methodology to create a lexicon called Senti-Ngram and proposed a rule-based approach extracting the Ngram sentiment scores from random corpus containing product reviews and corresponding numerical reading on a 5-point scale. The scores from this automated procedure are compared with that of the human annotators using the t-test and found to be statistically equivalent. This paper also proposes a sentiment classification methodology by using a ratio-based approach based on counts of positive and negative sentiments of a document. The second contribution in the AI and ML typically, again in the domain of sentiment analysis, is cross-D vectorizers, a set of feature spaces for cross-domain sentiment analysis from consumer reviews. The paper was published in Multimedia Tools and Applications Journal. So typically, this paper addresses a unique issue of sentiment analysis from the consumer review, and supervised sentiment classification approaches required labeled training, sources and testing target dataset. Generation of such dataset demands substantial time and efforts, but cross-domain classification minimizes the effort by considering two different domains for source and target datasets. So typically in this paper, we propose cross-D vectorizer, that means a set of 3 sentiment Ngram feature spaces, and this includes lexical TF-IDF. So TF-IDF stands for term frequency inverse document frequency, lex delta TF-IDF, and SEND send for the purpose of cross-domain analysis. We constructed the features by extracting the sentiment unigrams combination with the intensifiers and negations from the source data sets and utilizing an existing lexicon. The scores of these features are compared and computed in three different approaches. The scores for each feature computed by multiplying sentiment value with corresponding TF-IDF rating, delta TF-IDF, and feature importance values, which is FIV respectively, and importance value of each SEND, that is sentiment W8 of n grams in dataset. Feature is calculated by multiplying the number of times the features appears in the reviews and the logarithm of its inverse frequency in the corpus. So typically this paper explains using maximum entropy, support vector machine, and k nearest neighbors classifiers on three benchmark datasets, one proposed dataset for cross-domain classification. And typically we found that the proposed approach has shown improved results in comparison with some of the existing methods. Let us look at the interesting example when we talk about the AI/ML and technology in streamlining or enhancing the competitiveness of logistics and supply chain management. The most interesting example and the contemporary one, how Blinkit manages deliveries in 10 minutes. So let us look at what exactly they are doing and what kind of technology they are using. So Blinkit employs microservices architecture to manage its diverse functionalities. Each microservice handles a specific aspect of the platform, that may be the management, inventory control, delivery logistics, and this modular approach enables Blinkit to scale efficiently, deploy updates independently, and maintain flexibility in its operations. The benefits are scalability, services can be scaled independently based on demand, resilience, failures in one service do not hamper the impact or has the impact on the entire system, agility, teams can develop and deploy the features rapidly. Blinkit uses real-time inventory management, and typically this is the secret behind lightning fast delivery. So the platform uses an advanced inventory management system that integrates with local warehouses, real-time updates that ensures the stock levels are accurately reflected. The technologies used for this purpose are in-memory databases, technologies like Redis, which are used for fast real-time data access, and event-driven architectures like Kafka or RabbitMQ handle inventory events, ensuring synchronization across services. Geospatial optimization is another approach in the Blinkit platform, and typically it ensures the delivery efficiency, which relies on sophisticated geospatial algorithms. Platform utilizes geocoding to convert addresses into the coordinates and employs the route optimization algorithms to deploy the fastest delivery paths. And typically, it utilizes APIs like Google Map or Mapbox, which provide geocoding and routing functionalities, and the route optimization algorithms like Discrasta or A-star are used to compute the most efficient routes. Dynamic pricing and promoting engine, typically for considering the factors like demand, delivery time, and location, the promotion engine offers discount and deals tailored to user behavior and purchasing patterns. The components, machine tool models, predictive models are used for forecast demand and adjust pricing accordingly. Real-time analytics is used. Tools like Apex, Spark analyze user data to derive the personalized promotions. On the other hand, Blinkit deploys the customer experience and personalization, and for this purpose, platform leverages personalization algorithms, typically algorithms such as collaborative filtering and content-based filtering, to enhance product recommendations and provide a personalized experience to the users. User behavior analytics is performed using the tools like Google Analytics and mixed panel track analyzer with the which analyzes the user interactions. So if we broadly look at the domain of AI and ML and its applications utility for logistics and supply chain management, typically next generation logistics, then AI and ML empowers the organizations in terms of requirements planning, in terms of sourcing and procurement, manufacturing, quality assurance, and logistics and delivery, and putting together, you can handle your material sourcing and optimal pricing area, accurate demand forecasting and inventory planning, quality assurance, computer vision, delivery logistics, self-driving, delivery trucks, drones, autonomous vehicles. You can have integrated production plan with real-time risk management strategies, and typically, most important is to have the predictive maintenance of the assets. So AI-powered logistics and SCM help the organizations to manage their entire supply chain and logistics functions in a more smarter, efficient, and effective way, which accommodates the user requirements, accommodates the fluctuations in the market, and provides the personalized experiences to the buyers. Let's look at a couple of important advancements and the evolution of artificial intelligence and machine learning. So typically this domain has evolved over a period of say 60 to 70 years, and 1950 first industrial AI robot Unimat was introduced. 1960 Joseph Vanzobau developed ELIZA, that is natural language processing program. 1970 the ability of machines to make decisions on their own was made possible. 1980 companies adopted expert machine learning system to improve their business processes, optimize their parameters. 1990, IBM showcased how AI could solve complex problems. 2000, an autonomous car by Google with the help of AI and ML was introduced. 2010, market of AI experienced phenomenal growth of more than $35 billion in investment. 2020 to 25, our contemporary period, recent time, wider usage of AI in financial transaction, logistics, supply chain, and personalized shopping experiences is really changing the game of businesses. So this is just the details of the evaluation we discussed. 1950 was the first industrial robot, Unimat, then 1960 ELIZA NLP program, natural language processing program. 1970, it was the business processes which were made more intelligent, and the AI system has really improved the decision-making capabilities. 1980, companies adopted expert ML system to improve their business processes. 1990, IBM showcased how AI could solve the problem. 2000, autonomous car by Google. 2010, market of AI experienced phenomenal growth of $35 billion. In 2025, in the recent time, we see a lot of advancement in finance, banking, e-commerce, and this is something where AI and ML is really adding to the competitiveness of the businesses. If we look at this broader domain of artificial intelligence, then it is a broad concept of enabling machines to perform tasks that typically require human intelligence. It includes the aspects like reasoning, problem solving, perception, and understanding language. And typically, AI aims to create systems that think and act intelligently. If we look at the broader domain of AI, then it is a technique which enables machine to mimic human behavior. Within this, we have machine learning, which is a subset of AI technique, which uses statistical methods like regression analysis, like correlation analysis, and different kind of statistical tools and techniques to enable machines to improve with experience. Deep learning is again the subset of AI, and ML which makes the computation of multi-layer neural network feasible. So machine learning is a subset of AI, and it focuses on enabling machines to learn from the data. They recognize the pattern without explicit programming, and instead of being told exactly what to do, ML algorithms analyze data, identify patterns, and use those patterns to make predictions or decisions. So for example, you are analyzing the demand data, and your ML algorithm will capture the pattern hidden, and based on this pattern it would enable the prediction or forecasting. Similarly, you can use it in the predictive maintenance. So ML is all about how we teach AI to learn. So broader classification of AI and ML models: artificial intelligence, engineering of machines that mimic the cognitive functions; machine learning, ability to perform tasks without explicit instruction and relying on patterns, so I'm learning from the data; and deep learning, machine learning based on artificial neural networks. Let's try to look at the broader classification of AI, artificial intelligence. You can have narrow or weak AI, and typically this type of AI is designed to perform a specific task. Most AI systems currently in use fall into this category. It may be virtual assistants, recommendation system. I just talked about my recommender system using sentiment analysis papers, and image recognition software. The second one is general or strong AI, which has a wider applicability. So it is the AI with human-like cognitive capabilities, capable of performing any intellectual task that a human can. So this type of AI is still largely theoretical, and the advancement is taking place. And super AI, it is typically the hypothetical form of AI that even surpass the human intelligence in all aspects. If you look at the machine learning classification, then broadly, we have supervised learning and unsupervised learning. Supervised learning models, they learn from the labeled data where the input and the desired outputs are specifically provided. For example, you may have classification, you may have regression analysis predicting house prices. Unsupervised learning, typically the models falling under this category discover patterns and relationships without explicit guidelines. Examples could be clustering, customer segmentation, dimensionality reduction, simplifying complex data, and so on. Further, we can classify the machine learning as per the nature of learning. So it is reinforcement learning or semi-supervised learning. So reinforcement learning typically learn through trial and error, receiving feedback in the form of rewards and penalties. So if the outcomes are positive, then it would be considered as a reward. Otherwise, the penalty will be associated to unlearn and try to put your learning direction in the appropriate way. Game playing, robotics, typically teaching robots to navigate. Semi-supervised learning, it's a combination of supervised and unsupervised learning, and it utilizes both label and unlabeled data, and it is very much useful when labeling data is very much expensive. So chess playing AI and many such type of games can fall into this category. Deep learning can be classified as it is the subfield of machine learning. It utilizes the artificial neural network with multiple layers, and typically they are called the deep neural networks. So key classification or types include convolutional neural network, CNNs, primary use for image and video recognition; recurrent neural network, RNN, used for sequential data such as natural language processing and time series; and transformers. Models have become very important in the field of natural language processing, and typically they are the base for large language models. So broadly, if we just compare, then artificial intelligence versus machine learning and deep learning. So Artificial intelligence is a field of computer science focusing on creating systems capable of performing that require human intelligence. Machine learning subset of AI involve training algorithms to learn patterns, and deep learning typically it uses the neural network with many layers to model complex patterns in the large data set. Similarly, artificial intelligence encompasses ML, DL, NLP, robotics. Machine learning includes algorithm for learning from the data, and deep learning specialized neural network based algorithm. AI has a lot of applications include chatbots, self-driving cars, game AI, virtual assistants. Machine learning has applications which include email filtering, recommendation engines, predictive maintenance, and deep learning has the applications like image recognition, voice assistance, natural language processing, and so on. So this is broadly the classification we have appreciated. So we can put it in a different way. Artificial intelligence is a rule-based system, game playing, knowledge representation, and reasoning. Proportional calculus, search algorithm, planning, cognitive modeling all fall into the broader domain of artificial intelligence. When we say machine learning, we have support vector machines, linear regression, logistic regression. Typically, it utilizes statistical techniques, K-means clustering, random forest, Gaussian process regression, and deep learning. You have MLP, CNN, GAN, RBFN, RNN, autoencoders, LSTM, and so on. So use of AI and ML, if we look at broadly, then first, it is very much useful for demand forecasting. Second, for inventory management. Third, for route optimization. Fourth, for warehouse automation. Fifth, supplier relationship management and sharing real-time data. And sixth, it is quality control and inspection. So broadly, we appreciate the demand forecasting as one of the most critical area in supply chain and logistics, and AI/ML algorithms analyze vast data set that includes the historical sales, market trends, external factors like weather, economic indicators, and helps us to accurately do the demand forecasting. Similarly, inventory management, it can help to have real-time visibility into inventory levels, track movements, predict record reorder points, and improves the accuracy. Warehouse optimization, we can make use of the robots, automate tasks like inventory counting and tracking, and we can have very good real-time information and capacity utilization data to monitor the warehouse management system. Route planning and optimization, it considers the various factors like traffic, weather, delivery schedule, which is many times not possible to accommodate with the traditional statistical forecasting or route optimization algorithms. So route planning and optimization with AI can really help to accommodate diversity of the factors, and it reduces the fuel consumption, speeds up deliveries, and lowers the emissions. Predictive maintenance is one of the very critical and important area. So AI will analyze the data from sensors and IoT devices to predict equipment failures before they occur, and you can take the proactive action to avoid the fatality or the accidents. Similarly, risk management like supplier performance, geospatial risk, natural disaster, AI can greatly help. Supplier relationship management, we can track the supplier performance, risk factor, opportunities, we can identify the pattern and recognize the importance or criticality of the supplier, and based on that, the necessary contracts for supplier relationship management can be created. Enhance supply chain visibility, we can make use of IoT coupled with AI, and that can provide real-time tracking of products from production to the delivery. So the benefits are enormous. We can reduce the operating cost using AI/ML. We can improve the efficiency of operations, speeds, decision making. We can increase the accuracy like inventory management, demand forecasting, enhance customer satisfaction, greater resilience. We can respond to disruptions very fast, and that ensures the business continuity. And sixth, we can improve the sustainability by having the optimized delivery routes, reduce wastages and carbon footprints. Let's look at the real life industry examples of AI and ML application in logistics and supply chain management. So Amazon is one of the classic example which has automated the warehouse and demand forecasting using AI powered robots which handles the tasks like picking, packing, sorting, significantly increasing the efficiency. Demand forecasting, Amazon's AI algorithm analyze amounts of data to predict customer demand and allowing them to optimize inventory levels, ensure product availability. UPS is using route optimization, Orion, that is on-road integrated optimization and navigation, which leverages AI and machine learning to determine most efficient delivery routes. This enhances my speed as well as the timely delivery by managing the factors like traffic pattern, delivery schedules, customer locations to optimize routes and so on. So Orion is basically designed to optimize delivery routes for UPS drivers, and it uses the advanced algorithms and data analytics to create the most efficient delivery routes. The key features are route optimization. It analyzes amounts of data, including delivery schedules, locations, dynamic routing. Orion can adapt to real-time changes, traffic jams, navigation. It provides navigation with turn-by-turn directions, ensuring they can easily follow the optimized routes. And the impact is savings, cost savings, reduced fuel consumption, reduction in companies' carbon footprint, sustainability is improved, and efficiency of delivery processes. The another example is Walmart, which uses inventory management and supply chain visibility for the supply chain visibility. So AI helps Walmart to improve the inventory management by ensuring that products are in stock when customer need them, and it improves the visibility across suppliers and stores, enabling them to identify and address potential disruptions. Companies are using predictive maintenance, AI for predictive maintenance, vehicle or heavy machinery, which requires the periodic or proactive maintenance. AI algorithm can identify their usage pattern and when they are likely to fail, allowing for proactive maintenance and minimizing the downtime. Typically, the freight industries, they use the sensor data from the vehicles to predict when those vehicles will need maintenance. The another domain where AI/ML is significantly utilized in logistics and supply chain is freight matching and optimization. So companies like Convoy, they use AI-powered platforms to match shippers with the carriers and optimize load efficiency, reducing empty miles. So you don't have to really move your say cargo partial truckload. You can have the full truckload. You can aggregate your cargo, and your freight efficiency can really be improved. So platform analyzes the data available on capacity, shipping, routes, market condition to find the best match, reducing transportation cost and environmental impact. So our key takeaways: use of AI/ML in logistics and supply chain management addresses various challenges which are otherwise highly complex to handle using the traditional statistical algorithms or optimization approaches. Automated warehousing operations to optimizing delivery routes and predictive maintenance is a broad spectrum where AI and ML is efficiently utilized. The ability of AI to analyze the large data, find patterns within that data is really create the difference for the businesses and put them all together on a different frontier in the competitive landscape. So AI/ML model, it has a great versatility for entire logistics and supply chain management. Inspiration right from the stage of idea generation, concept, risk estimation, future analysis, success, your business processes, strategy, technology, marketing, all domains, AI and ML is really helping the businesses with its versatility to improve their competitiveness. So, to summarize and focus why AI and ML is extremely important for SCM and logistics, first is demand forecasting models. So time series analysis, your ARIMA and Prophet are highly used model. ARIMA, which stands for Auto Regressive Integrated Moving Average, is a statistical analysis model that uses the time series data to either better understand the data set or to predict the future trend. And Prophet model is an additive regression model, which is a piecewise linear or it could be non-linear or logistics growth curve trend. Machine learning regression models are very much in use, like linear regression, random forest, gradient boosting, and so on. Inventory optimization models, we are using reinforcement learning. So typically these models learn optimal inventory policies by interacting with the environment and adapting to changing conditions. So today we are living in the VUCA world and the inventory fluctuations are highly dynamic, and it is important for the businesses to learn about these patterns and adjust their stock accordingly. Clustering algorithms, K-means, typically can segment inventory items based on their demand pattern, and it allows them to tailor inventory management strategy for fast moving items and slow moving items. Route optimization models, you can have graph neural networks which analyzes the complex network, for example, your transport networks, to find the optimal delivery routes. It considers the factor like traffic, distance, delivery windows. Genetic algorithms, evolutionary algorithm, they find the near optimal solutions to complex problem, combinatorial problem, and they are very effective from problem solving, which involves many constraints and variables. Predictive maintenance models, anomaly detection algorithms, isolation forest, one class SVM are highly useful to have the predictive maintenance, proactive maintenance, which reduces the downtime. You can make use of deep learning models, recurrent neural networks, convolution neural networks, and this model analyzes time series sensor data, image data to predict equipment failure with very high credibility and accuracy. Risk management again is a domain, very important domain in the logistics and supply chain management, and you can effectively use the classification model like logistic regression, decision trees to understand the factors such as supplier performance, geopolitical risk, and how this can be mitigated. Natural language processing can help to analyze new articles, social media, and other text data to identify the potential risk and disruptions. So there are certain cautions before we really just get into the use of AI and ML. Number one, the choice of model, AI and ML model, depends on the specific problem. I have highlighted variety of the problems and the kind of AI and ML model which is extensively useful. This indicates that the model depends on the specific problem, the available data, and the desired level of accuracy. Data quality is crucial for the success of any AI ML model. And number three, continuous monitoring and model retaining are essential to maintain accuracy and adapt to changing conditions. So the future of logistics and supply chain management with AI and ML is highly promising. Predictive analytics and prescriptive insights, AI and ML will help logistics and supply chain management across the sectors, autonomous supply chain operations, AI-driven supply chain networks, AI-powered sustainability and resilience, and blockchain and AI integration are some of the futuristic trends which are very, very much promising, and the organizations which will get adapted to these changes, these trends very fast, will really leverage the competitive advantage. So the various AI and ML, the future logistics, lies in the demand forecasting, leveraging the efficiency of AI&ML, route optimization, warehouse automation, use of collaborative robots or cobots, predictive maintenance, supply chain visibility, tracking goods and material in real time. All these are very, very typical and critical areas where AI and ML with improved and advanced version is giving the competitive advantage to the organizations. Risk management, autonomous vehicles and drones, enhanced customer experiences are critical areas which are shaping the future of logistics and supply chain management with AI and ML. So what we would see in the coming future with AI and ML, increased automation from warehousing to transportation, all aspects of supply chain, greater integration of IoT that will gather the wealth of data, blockchain integration, enhanced supply chain transparency and security, hyper personalization of the supply chain services, tailoring deliveries and services to individual customer needs, and sustainability. So it will optimize the supply chain for sustainability, reducing the wastages and emissions. I hope this session would have helped you to appreciate the critical and competitive use of AI and ML in the domain of logistics and supply chain management. I would like to conclude the session with a brief about my university, Gati Shakti Vishwavidyalaya, India's first and only university in transportation and logistics sector, has a unique role to play in terms of creating highly skilled manpower for all the modes of transport, rail, road, aviation, water, ports, and shipping. GSV extend programs held all the levels, undergraduate, postgraduate, PhD, executive training to enable nation's aspiration to reduce its logistics cost from present 14% to 8 to 9%. Transportation sector is a growth engine for India. It has a significant impact on the economy and GDP. And in this line, university offers demand-driven curriculum with a focus on all three dimensions: technology, that is infrastructure; management, that is services; and policy, that is regulation. In line with the vision, innovation-led industry-driven university, Gati Shakti Vishwavidyalaya has collaborated with various industries such as Airbus, Nippon Koi, Nokia, all top and leading industries, Siemens, Jacobs, Plaza India, Railtel, and many others. Thank you for your interest in learning the various dimensions of excellence in logistics and supply chain and infrastructure projects. We will keep exploring more issues through this platform for the benefit of industry professionals. Thank you very much.